All right, let's go ahead and get started. We're going to talk about retractable roof stadiums today, and I'm going to try to keep it brief. I will definitely be under 15 minutes. If I'm not, then I'll skip that. So Walter P. Moore, I'm not going to take much time here. We're a 93-year-old company, been in India for 13, 14 years now, and recently started a Bengaluru office, about 170 people in India. So retractable roofs, we've been doing retractable roofs for quite some time, and I just wanted to give you a flavor of all different kinds of roofs. Not going to talk about any one project in details, but just the roof aspect and how we make those roofs move. So here are 7 projects that we've done since 2000 in the past 24 years. So except for one project, I think we've done pretty much all the retractable roofs in the US. But before we get to that, the first question is why retractable, right? I mean, why do we need to have a retractable roof? So if you go for a tennis match or some Wimbledon or somewhere else, and and if you're a fan of Nadal, then you want to see him play, and you want him to see him drenched in sweat. You don't want him to stand on the sideline and drenched with the rain. So that's why. So event assurity, that's one of the main reasons for doing retractable roofs. So I'm sure there'll be some brave soul who will be there with an umbrella, but the concept is to put an umbrella over the entire roof. So that's the idea, which can be opened and closed. The business case is pretty obvious. So event assurance, if there's going to be an event, it better happen at that time. There's a lot of money invested in having the event at the same time. Spectator comfort, obviously, if it's going to be raining or if it's going to be too hot or too cold, and that's why you can close the roof and you can control the temperature inside. Another very important aspect for something like a football or where there's a natural grass, then because of opening the roof, you can let the sunlight in and the grass can grow in natural conditions. Multipurpose, this is something that's very applicable in India, I think, because in a smaller stadium, maybe not a big stadium, but like an arena or something like that, we do a lot of different events. I've been to weddings which happen in stadiums and arenas, so you can have different types of events. And competitive advantage, if there's one stadium which can guarantee you that the event will happen versus which not, then then obviously you want to go with the one where you have a guarantee. And prestige, I guess, I mean, when buying a car, sometimes people like to have a sunroof or moonroof, you're compromising somewhere else. So that's something that also kind of comes with that. Quick question, anybody knows when the first retractable roof was built? 2000s, 1990, 80s? If anybody is thinking 80s, they're correct. It was 80 BC. The Colosseum was the first retractable roof. I'm not going to go into the details on how it was funded and all those things and different things, but a 50 to 75,000 capacity stadium, if you will. And the idea, it was theorized that the retractable sailcloth was used, and there was 240 wooden posts set in the socket and rings. So you can see the evidence of that, the support and the socket. And does the other picture show? Oh, here it is. So the Roman Navy, they used to have the operators with the roping, and they had a lot of ropes and rigging expertise, and they used to kind of cover the stadium. So it's been said that this is the first retractable roof stadium. All right. So looking at the clock, I'm going to quickly go through a few of these. So this was one of the first one that we did in the Astros Stadium. This is in Houston. Very old style stadium. You can see there's a linear linkage on one side and fixed on the other side. And there's a transporter girder and suspension system that makes it move. One thing to kind of remember in a retractable roof stadium of any kind is that it's not simply just a roof on railers like a rollerblade. So you have to account for the movement, you have to account for constructability, you have to account for the lateral movement that can happen. And so there has to be ways of accommodating movement. And so here in this case, there was a release hinge at top, and it was kind of a rigid column supporter at the bottom. So the transporter at any moment would remain straight. So even if there's movement of the rail happening, if there's horizontal load, it will still open and close. Because there was a lot of stadiums before 2000s that the retractable roofs didn't actually open. They opened for a few few years and then they didn't. Even the stadium in Wembley, it was supposed to open in kind of 10 minutes or so, and within the first few years, it went down to more than hour and two it takes to open. Reliance Stadium, also in Houston, again similar, different kind of structure here. There's two what we call super columns. So there's basically 4 columns and 2 super trusses. So different kind of structure. However, the idea is the same. In this case, there's a 4-bar linkage which supports that, and so the roof transporter will always remain vertical even if there's horizontal thrust on the roof or if it's out of line or anything like that. One thing I should say is on all of the retractable roofs, there's a mechanization consultant in all these roofs. It's a company called Unisystems. So the structural engineer and the mechanization consultant have to work in tandem to get things right. I like to show this picture because the stadium over here that was built in 1965, that's the Astrodome. This was the first dome structure in the world, and this was designed by Mr. Walter P. Moore himself, and that's the one, the stadium next door is what it replaced. By the way, just a fun fact, this Astrodome was the first stadium where artificial turf was used, and that's why it's called AstroTurf still in some cases. The University of Phoenix Stadium, this is where the Arizona Cardinals, it's an American football team, plays here. Similar kind of concept as the one before where there's 2 kind of super trusses on super columns. These trusses are Brunel trusses, and they were installed on the ground and hydraulically lifted to the place. And another thing here is this lenticular roof panels, they're supporting, this is fabric roof, this is the PTFE roof, the same one that we've used on the Motera Stadium as well. So it gives the clarity, and this is a shot where you can see the roof open and it closes. Again, similar kind of thing, but there is a linear bearing in this one. And all these retractable roof stadium, they are kind of have a roof control system where there's cameras and motion detectors, so it kind of tracks and makes sure that both the sides are going at the same time, and if not, then it autocorrects itself. So there's an automation that goes in there, and there's limits have been set on, okay, at a particular wind speed, only at this thing, if there's some big storm coming or something like that, you cannot open or close the roof and so on and so forth. Interesting thing about the University of Phoenix Stadium is the field is also retractable. So the entire field can go outside of the stadium where the grass can grow, and like I said before, the stadium can be used for different things. Other than playing football, there could be a concert or something else happening, which at that time it doesn't kind of spoil the grass. Lucas Oil Stadium, this is in Indianapolis, a very different kind of looking stadium, very industrial, warehouse kind of look, because that's what Indianapolis is. And here you can see that, there's also a retractable wall here, which opens up and kind of, you can get a beautiful sunset view from here. Similarly, I didn't have an aerial view, but in this one, there's like 8 panels which just slide up and down. So very different kind of concept. The whole thing doesn't move in and out. I'll skip the Cowboys Stadium, come back to it later, but the Marlins Stadium, all the roof stacks up on one side. This is in Miami, so hurricane country. We did a wind tunnel test for all of these, but this one in particular, because at hurricanes, what we realized later on that if you actually keep a little bit of gap between the panels, then the pressure is actually reduced. And that was proven, and so that's how it was done. There's a lot of other things. There has to be hurricane tie-downs and things like that, which kind of keep everything in place. And the last one that we've done recently is the Globe Life Field. This is in Dallas. This is, again, a baseball stadium, and the entire roof kind of goes and parks on the side, where there's another event that happens when the roof is on the other side. So there's usable space on the other side. So the roof is being shared by 2 spaces here. This is how it looks from inside. This one we haven't designed, but I just still wanted to show this because it's a different kind of concept. This was a stadium in Vancouver, which was built in '83, and then a roof was added to it on 2012 with external kind of supporting structure. And you can see here that there's cables, and the roof kind of, it all bunches and goes to the center. Different kind of concept. There's a lot more moving parts. Not extremely, I want to say, successful from a movement standpoint, but a different concept, so I wanted to show that. And this I'm coming to last one because this is very close to my heart. This was one of the projects that I designed when I was in Dallas. This is the Cowboys Stadium in Arlington. This is the world's largest, and both the walls also open up. This is a huge open plaza, and this has many world record. It has the longest single spanning roof structure, which is a 1,225 feet arches, biggest dome. It had the largest video board at that time. Now one of our other stadiums, SoFi Stadium, has the largest video display. So this is what it looks like. The two center panels open, the two big arches that span on two sides. And these are really big, just to give you a sense of scale. Not much to talk about here. But the ring beam on the outside, this is where the outside support for the fixed stadium is. Just a schematic diagram, the two arches, then the fixed 2D trusses on the sides and in between, and those are the two that open up. Quickly, just because I was part of designing of the arches, I like to show that this 14 by 730, those are the four members on four sides of the arches, and 14 by 730 means each foot of that section weighs 730 pounds. So that's pretty heavy. But if you look at the arch, it looks pretty small. There are 35 feet deep arches, 17.5 feet wide, and it has, the thrust force is 19 million pounds, so there's a huge abutment that takes that load, and it's kind of transferred in friction. There's 170 feet long, two walls that transfer the load in friction. Another view after it was deshored, and internal view showing the thing. Beautiful stadium in my view. I might be biased. But again, here there was a 4-bar linkage, as you might be seeing this. The way this, to accommodate the movement, we kind of kept on improvising on that, and this is a little bit more slicker. Another outside view with the doors open, the retractable doors, and a beautiful inside view. This, just to give you a reference, this scoreboard that's hanging from the top, that's also retractable. It can come down depending on the events, it can go up, and that's as tall as a 7-story building that's hanging from the roof here. All right, the reason I'm speaking so fast because I wanted to get to this. So what we now say is clear is the new retractable. Because retractable roofs, as you can see, they are big. For big projects, it takes a lot of energy, it takes a lot of material. So clear is the new ETFE, is kind of the clear roof, and I'll show you what it is. But it transmits light, it's lightweight, it's free form. You've seen the structures with the self-cleaning. So it's aesthetic, better performance, cost is also better. So this is what it looks like. And it can be a single layer, or it can be a pneumatic panel like a pillow to kind of span higher. So as you go towards a thicker layer, I mean, obviously the transparency reduces and the performance on the thicker layer is better. So this is one of the latest stadium that we did. This is the SoFi Stadium in LA, and this uses the ETFE. And as you can see here, I don't know if you can see it or not, but there's these smaller micro openings. So this is 60 feet by 60 feet, smaller openings that open up. The rest of everything is covered. And this entire roof is it also covers another auditorium on the side. And the fault line in California is very close to this, so the entire stadium is depressed, and the whole thing is supported over bearings, so it can move in case of an earthquake. This is what it looks like. This is a rendering. 2 minutes to go. Okay, so we're talking about big stadiums, big and houses, but retractable roofs or kinetic architecture, it can be on a smaller scale as well. So it can be on a mall. This is a mall in Salt Lake City where the roof opens up. So when we are talking about retractable roofs, it not necessarily has to be something really huge that we are talking about. This is California Academy of Sciences, again another retractable roof. This is the Margaret Court Arena. Not very small, but the smaller one, it's also, and very, what do you want to say? It's very economically designed structure. So retractable roofs can be very beneficial in a country like India. We've been talking about some conceptual things for cricket stadiums, and I don't know if Mr. Surya Prakash from L&T is in the room or not, but he would, yeah. So he would be able to add some value on the cricket stadium and retractable roofs. But that's something that can be done, kind of thinking about different things. It may not be the entire roof that can be covered and so on, but smaller retractable roofs definitely be possible. So like I said, it's not only tennis, but our cricket fans and the World Cup also, they were stranded India-New Zealand semi-finals match. And so a retractable roof stadium could be beneficial in something like that as well. Thank you. With 48 seconds to spare. Thank you very much.